Hi, my name is Márton. I'm a developer advocate at JetBrains, and I'm really happy to be talking to you about Compose Hot Reload today. I think it's one of the most exciting things that we've built in the Compose realm in the last year or so, and it is coming up on being a one-year-old project. I've been running on it, I think, since November. And really the best way to explain what Hot Reload does is to just show you Hot Reload in action. So we're going to go straight to a demo, and we'll be doing a bunch of live demos and live coding during the talk, which will surely go just fine. I'm also on the latest nightly internal build of IntelliJ IDEA, just for kicks, and also to show you the latest version of our tooling for it. But this all also works and is coming to Android Studio, of course, as well. So let's see what we can do with Hot Reload. As I mentioned, I have IntelliJ IDEA here, could also be Android Studio. And importantly, I have the Kotlin multi-platform plugin installed, which gives you all the tooling you need for working with KMP applications. One of the small things that it gives you is that if you have a project with Hot Reload configured, you can easily launch it with a Gutter icon. You get this nice little flame icon here, and you can launch a desktop app running with Compose Hot Reload through that. This is a significant point in the talk because we have launched this app and we're not going to relaunch it at any point during the talk. We're going to hopefully go through this entire thing without having to stop the app and then reopen it. The project, as you can see here, that I'm using is the Kotlin Conf app, which is one of our flagship samples. It's also open source, so you can see what it's like on GitHub. You can check it out. You can play with Hot Reload in the project if you want, and so on. Let's go to one of the screens here, one of the simpler ones perhaps. We have this info screen in the app. And what Hot Reload is going to allow you to do is easily edit your code and then see the changes that you've made essentially in real time in a live running application without having to rebuild and restart it. So let's say that we want to change some of the spacing here between our different items on the screen. So all of that's arranged in a column somewhere. We have a spacing somewhere in there, and we can try changing that to, say, 32 dps. And as I save the file, you'll see that Hot Reload kicks in. It recomposes the code, and then injects the new version of the code into our live application, and it recomposes so that we can see the new padding values. Again, without having to close the app, rebuild it, relaunch it, navigate back to the same screen. And this allows you, obviously, to iterate very quickly to try different values for the UI things that you're working with. But of course, we are not limited to making small changes like this, like editing a constant that's in there. We can make more significant changes as well, and that's where Hot Reload's real power is, that you can make almost any change in your code, and it will reload it for you. So let's start making some more interesting changes. You can, for example, change the structure of your code. Say you want to remove one of these social squares from the bottom. If I remove that from my code, you'll see again that Hot Reload kicks in. It recomposes for a moment, and once it's done with that, it's usually a lot faster than this, then you can see that we get the change. And of course, if I just go ahead and undo this, it will reinsert that, and this compilation is a lot quicker because we are hitting cache at this point, because we were already in this state before. We can also try adding new UI. So all of these social icons down here are currently just a single icon, but I can, for example, add a text to them as well. So maybe I want to wrap these in a column, and other than the image, I can add a text here. We already have a description as a parameter because of the content description parameter, and I can save this and see if I built something sensible or not. And well, I've made the icons disappear and the background and the whole card disappear, so I probably want to fix that. I can try moving these modifiers up to the column and see what that would look like. And that's still not quite right, so I probably want to make this slightly larger, and I think I need to center it horizontally for it to look sensible. So once again, I can do that, save it, and now I have my new UI there. So I can add new elements like this as well. Something that's even more interesting from the reloading point of view is that I can also create new functions, new classes, change the parameters of existing functions, and larger changes like that. So for example, if I select this row, which contains all of these little social links on the bottom of the screen, I can extract that into a new function, call it social row or something like that. And just to see that we have indeed made a change, let's change like a weight on one of those modifiers at the same time. And once again, once this recompiles, it will load right into our running application, and we can see the change immediately. We can also try interacting with the app. We can, for example, try opening the Slack link that's here. And we can see that as I click that, it actually opens Blue Sky. And if I try opening Blue Sky, it is actually trying to open Slack. So we have these wired the wrong way around. So let's see why that is happening. If we follow our callbacks, we can find where these are being handled. And it seems like we have the right code here. Slack is opening Slack, Blue Sky is opening Blue Sky. But if we go to these URLs, we'll find that we have just the string constants swapped around. But luckily, we can fix this with hot reload as well. So even these static constants that we have here can be hot reloaded. So if I change this around, wait for hot reload to happen. Now if I click the Slack icon, it is opening Slack. And if I click Blue Sky, it indeed goes to Blue Sky. So even a change like that can be hot reloaded, which is quite nice. We can also go to the settings screen, for example, and see what we can iterate on using hot reload there. We have a nice animation here, which allows us to switch between dark and light themes. So as I switch, you can see that we have some kind of built-in animation there. But we might want to play with that a bit more. In fact, this settings screen is quite empty because on the desktop version of our app, we have some of the settings hidden because they're not relevant, like we don't have notifications implemented on desktop, for example. But if I find that code, of course, I can very quickly just override the feature flag with an if true for you, and I can show you what the rest of the screen would look like if we were on mobile. So if I wanted to iterate on this UI, I could just reveal it quickly just during development and tweak it a bit, and then hide it again, reverting this one line here. Getting to that animation, though, we can find that somewhere up here. We can see that this is powered by a bitmap animation. And of course, this is something that you might want to tweak a bit. You might want to play with the timing. You might want to play with the easing of how exactly that swipe happens. And this is really, really convenient to do with Compose Hot Reload as well, because you have your live app right in front of you. You can change the timing. For example, change this to like more than a second. And then as you rerun the application, you immediately have a feel for what your changes look like in an app. So this is what a slower animation would look like. And we can play with adding some easing. We can try, well, there's a lot of options, obviously, but we can try like a cubic easing. And once that loads, if I click this again, we can see that there's now a bit of acceleration to that animation as it's happening. I also know that there's some nice bouncing easing functions in there. So maybe we want to try like ease out bounce. That might be a good one. Again, we just wait a second for hot reload to happen. And yeah, I think we can probably keep this one. It's a pretty fun way to change themes. I should also mention two things here. One of them is that as we were playing with these, we were, of course, adding things like new imports to the file. That's also perfectly fine with hot reload. So you can just pull in new code like that. And that can also be hot reloaded. And I also wanted to note that the speed of reload generally depends on your incremental build speeds. So if your project is larger, it's going to be slightly slower. But if your project is well configured and it has configuration caching and all of these things set up correctly, then you're going to have faster reloads. I'm showing this in this demo on a fairly real-sized app with realistic compilation times. If I was doing a Hello World demo for you, this would be completely instant, of course. But I want to show you what the real experience is as you're working in an application. OK, we'll get back to demos in a bit. But I do want to tell you a bit about how hot reload works now that we've seen it in action. So first of all, how do you add this to your project? To set it up, you need to add a Gradle plugin. You can see that we're currently in RC2, so we are essentially stable. We're just waiting for some other releases so that we can push things out at the same time. But we have basically gotten to 1.0 with hot reload, which is really nice. Then you'll need to add this to your settings Gradle file. This is a Gradle toolchain resolver convention. We'll get back to what this does in a second. And if you haven't updated your Kotlin version recently, you should add this compose feature flag to your project as well. But it's the default starting in Kotlin 2.2. So if you've updated since this summer or so, then you can actually forget about this. And it's a 2-line setup to add hot reload. So how does it work? Normally, when you have your build tool, say Gradle, launch your application, it will start the Java runtime and load your application's code into it. We are talking, again, about the desktop JVM app here. The first thing that we do to make hot reload work is that we make sure that the runtime that you're using is the JetBrains runtime. This is our own fork of OpenJDK, and it just so happens to have a feature that we'll need later. The way that we can ensure that you're using that runtime is exactly with this resolver convention. So even if you don't have JBR downloaded and set as your JDK, through Gradle, we can automatically download it for you and use it when you're launching the application. So the reason why we need JetBrains runtime is because it has something called DCEVM, which is a feature for advanced class redefinition. This is what allows us to swap almost any kind of code change from your old version of your code to the new version of the code at runtime. Another thing we do when you are starting your application is we inject a Java agent in there, which can interact with your application's code. Once your app is running, we do need a couple other components running next to it. Hot reload has a supervisor process, which coordinates everything that happens in the hot reloading process. And one of the things that it does is that it works with the recompiler. In the case of a Gradle build, this can be a continuous Gradle build with file watching, which is one of our options. And we also have integrations with the IDE so that as you trigger an IDE action or you save your files, we can trigger the recompilation for you. You get to configure this if you have preferences about when the reload happens exactly. Once your code is changed and recompilation happens, the results of that will be passed to the supervisor and then back to the hot reload agent, which will again use DCEVM and do this magic swapping of going from the old versions of classes to the new ones. Then we perform a lot of intelligent diffing here to figure out which parts of your UI were affected by those changes. So we figure out which parts of the UI will need to invalidate and re-render based on the changes that were just loaded. And finally, as the last step of reloading, we can talk to the compose runtime that's inside your application to essentially drop a certain subtree of your composable code and make it recompose, thereby running the new version of the code that was loaded and showing you the new version of your UI code. We also have some other things that connect to the supervisor process. I'll show you this once we get back to the demos. We have this little floating dev tooling window that accompanies your desktop window, and we also have some IDE tooling integrated with hot reload. All right, let's talk a bit about DCEVM. This is going to be a somewhat high-level explanation of it. Let's say that you have some of your current classes in your application, like we have this simple offset class here with just one property in it. And this lives in your current class loader as the app is running. What DCEVM does is that as the new version of classes come in, it will load those into a separate class loader. It creates this kind of side universe. Then it verifies that the migration is possible from the old version of the classes to the new ones, which is almost always possible with DCEVM. The one caveat is that you cannot change superclasses of existing types. For example, you can't remove an interface that was already there on a type because there would be no way of making that change at runtime. And once this verification happens, DCEVM migrates all the existing instances of classes over to their new versions and new layouts. And then that new class loader becomes the primary class loader, and your application continues from there. So what do I mean by just migrating objects from the old versions to the new ones? Well, let's say that we're still working with the same offset class, and we have a bunch of them in memory. The way that this would look like is that they live somewhere on the heap, and they have a certain object header, which every JVM class has, and then they have the area of memory that contains their actual values. In this case, with the one int property, it would just be a literal int value in each of our offset objects. So what we do is when we are trying to add, for example, a second int property to it, is that we need to allocate new memory for each of these offset instances because their memory layout is going to change. And then for any fields that were already there before the change, we can just copy those over to the new memory address and keep them as is, including the header and that first property. And then for any newly added fields and properties, we need to initialize them somehow. And here we just go with the JVM defaults. So for numerical values, it's going to be 0. For booleans, false. And for reference types, we're going to initialize them to null. And once this migration is done, we can drop the old version of the objects and continue executing the application from here. If you think about it, what we're doing here is basically a special garbage collection pass where we're stopping the execution of the application for a moment. We're moving a couple objects around in memory. We happen to modify the layouts of some of them, and then we continue from there. Once that swapping is done and all of the new bytecode of the classes is loaded, we also need to invalidate your Compose UI, as I mentioned, so that you can actually see the changes visually and not just have the new version of the code loaded into the VM. So here's an example where we have a padding function returning just a 16 dp value, and then we have a simple counter where we have a card, it has a button on it, and clicking the button just increments a counter value. So let's say that we change the value that the padding function returns from 16 dps to 32 dps. In the background, we maintain hashes of the bytecode contents of every function and every composable group that you have in your application so that we can detect changes in these. And we're also tracking usages through these hashes. I'm not going to go into details of how this works. I'll point you to a resource where you can learn the full story about this at the end of the talk. The point is that through these hashes, we are able to detect that after the reloading happens, that function has changed. So we can track where the usages of that function are. In this case, it's being used as the padding on our button. And then we can find the closest compose group that we're able to invalidate and recompose. So in this case, that would be the card that is wrapping our button. So we would drop everything that's inside the card, which would make the compose runtime recompose, run that code again, call into the updated version of the padding function, and show you the UI with the modified padding value. In this case, because we only drop the things that are inside the card, the state for the counter, for example, would be remembered still because it was not affected by the reload. On the other hand, let's try making another change in a slightly different scope. Let's say that I want to change the text of the counter here. In this case, the closest scope that we can invalidate would be the entire body of our current function. So in this case, we would drop everything that was already rendered for this function, which means that our counter state would also reset to 0. And as the code runs again, it would hit the text again. Now it has a new parameter, so it would show the new text on the screen. In general, we are going to try keeping as much state as possible and invalidating the smallest scopes that we can, but we will always choose correctness over keeping more state. So we want to make sure that what you're seeing on the screen always reflects the current state of your code, and you're not in this situation where you've changed some code, the UI has kind of updated, but you're not sure if you're really seeing your latest code or if you should relaunch your application to see it. So we really want to avoid any confusion and weird states like that. So we always want to go for correctness, and we'll drop whatever state is necessary to drop when we have to make a choice like that. But after the 1.0, this is something that we're going to look to improve to see if there are certain cases where we know that we can safely keep state while also having correct behavior. And with that, let's go back to the demo so that I can show you some more scenarios and some more of the tooling for hot reload. So I already mentioned the dev tooling. Let me show you that briefly. If I wiggle this window a bit, you'll see that there's that little widget on the top left, which is chasing it around. So that's the dev tooling window for Compose Hot Reload. We have a couple actions here where we can, for example, trigger a manual reload if we want to, and we have some other like debugging options. We have some info about the reloads that happened and when they happened, and we also just have the console logs of the recompilations. This was our initial implementation for dev tooling. We are now moving this more and more into the IDE. So we can also find the logs just in the run window. So as we were running the app and we had our normal log outputs like network calls and things like that, we're also injecting all of the recompilation info into that same log window, so you can easily find it. And we also have reload status presented in the IDE now. So in the top right corner here, we can see that we are in the green with hot reload, so we have a fresh working state. And we also have like a manual trigger here if we want to ever manually reload something. All right, let's hop over to the speaker screen next and search for example, all of the Sebastians who gave talks at KotlinConf. Let's also iterate a bit on this UI. We have a speaker card component somewhere. And we can try playing with something like the sizing of the avatars here. So again, this is kind of a basic change at this point, and you're used to this working with hot reload this far into the talk. But once again, we can modify values like this. I can hop over to the avatar. I can try what my UI would feel like if we had circles instead of rounded rectangles. And all of this you can very quickly, very easily try, which makes it really fun to iterate on UI and just try different constructs in there. Something that's slightly more interesting technically under the hood here is that we are actually working in a different module this time compared to our previous changes. So the speaker card component lives in a separate UI components module in this project, while all of the screens and the main parts of the app that we were touching so far were in the shared module. So hot reload, of course, also works across different modules just fine. We can also try playing with the grid here a bit. So right now you can see that we have this fixed 2-column grid, which is not very responsive. So we can hop over to the speakers screen, and we can look for wherever the grid is. And of course, we could again play with how many columns we have, but we can also quickly try things like an adaptive grid. So we can see what a 200 dp adaptive grid would look like. Once again, I would like to highlight that as we're doing this, we are staying on the same screen. We're keeping things like our search input, and we basically retain as much of the context of the application as we can. This 200 dp thing doesn't really work. It seems a bit tight, so of course, again, we can iterate and find just the right values very easily. We can go to like 250, and that's probably fine. We can probably go with that. We can have maybe a broader search so that we have more elements to play with. But I think that looks pretty OK. Something I should show you is what happens when you create a compilation error during your changes. So let's say that I just break this file completely, and we get into a red state. So at this point, hot reload will fail. We have this animation that shows you that hot reload failed to happen. Of course, your app is still interactive. This is just an overlay telling you that you're in a red state, and you probably want to fix it because you're not looking at the latest version of your code because it's not compilable. In cases like this, you can, of course, also go to the logs that I already mentioned. So because we channel all the recompilation logs into the main run window for you, you just get clickable references where you can jump exactly to the broken code and hopefully find the missing parentheses. And then you can just get back into a green state. And again, if you keep iterating from here, hot reload will continue working. So generally, it recovers just fine from these failed compilations because if compilation fails, we just don't load the new version of your code into the app. One more thing that I wanted to show you is hopping over to the schedule screen, which is, of course, this long list of sessions. This is all implemented with one gigantic lazy list, which has all kinds of different items in it. So it has these day headers, it has the time slot headers, it has these small sessions, it has the talks and all of this. And we also have a feature here which allows you to filter for just the bookmarked sessions that you have. So I have a couple sessions bookmarked here, but for other slots, you can see that they are just empty because I haven't bookmarked anything yet. So it might be nice to add a feature where we add just a small label into these empty slots, which tells you that you don't have any bookmarks in there. So for this, we can hop over into the schedule view model. And we can find that the way that all of these items work that are populated in the list is that they are of this sealed interface type schedule list item. So we have day separators, we have day headers, time slots, and so on. So what I'm going to do now is I'll add a completely new class to my code, which is going to be this no bookmarks item, which I'm adding as part of a sealed interface. And I already have some logic prepared here so that if one of the time slots didn't have anything added to it, I also want to insert an extra no bookmarks item into it. Now, because this is a sealed type, we of course get compile time safety around it. So we can again hop to the errors, and we'll see that of course on the screen side where we're handling these items from the view model, we have not handled the new item yet. So I can just quickly hop over here and map it to an ID for the key lambda. And then we have the actual when statement, which is rendering all of these different items to the screen. And for our new item, we can have maybe just a text that says no bookmarks here, or something like that. And as I do this, this will successfully get reloaded. You saw that we had a green flash. We're in a green state with reload. We also, by the way, see up here that we have reloaded 20 times so far during this presentation, all successfully. But we are not seeing our new items. So I have the logic in place in the view model to add new items into this list here for all the empty slots. And I have the rendering logic in place. But compose hot reload doesn't have a way of rerunning code that's inside my view model. Because if you think about it, the code that I modified in the view model for the logic part is just some function in my app. It's a private function inside a random class, and hot reload doesn't really have the context of how to rerun this code. If I make a UI change, it sees that it's part of my composition. It can invalidate it. Compose will recompose, and it will run the new version of the code. But if you're making code changes to other parts, there's no way for us to automatically rerun your code as well. But if we take a look at how the function is used, we can see that the view model is combining a bunch of different flows, and then it's going to call this build function to build the list of items. So because the code is already loaded in there, the new version of it, if we can rerun this logic somehow, then it will run the new version already. In this case, this is quite simple. I can just trigger the filters a bit. I can toggle it back and forth so that it will have to rebuild the list as I turn on the filtering again. And you can see that we have essentially implemented a new feature here. Again, adding a new class into a sealed hierarchy, changing business logic that doesn't live directly in the UI. And all of this was successfully reloaded, and as long as we have a way of rerunning it, we do get the new version of the code. The same thing would happen, of course, for something like a click listener that you have. If you change the logic and you can click the button again, it will run the new version afterwards. From here, of course, it's really just a matter of styling this text a bit because it doesn't look great at the moment. So we probably want to add some padding onto it. Maybe like 12 dps of horizontal sounds fine. And maybe we want to set it up with some color. Again, we have a theme here that we can go with. And yeah, secondary text probably sounds appropriate for this. So because these are, again, just UI changes and they're part of the composition, hot reload can just invalidate this for us, and we see the changes popping in almost in real time. All right, I think that's all the things that I wanted to show you on the live demo side. So we can hop back to the slides, and I can talk a bit about how you can get started with hot reload. The best place to go is the GitHub repository. It's at jb.gg/chr for compose hot reload, where you can find out more about how the project works. It has the setup instructions. It has a sample app in the repo that you can play with if you want to try that. And let's talk about this part. So everything that I did here was on the JVM desktop target using Compose multi-platform. And yes, all of this through the integrations that we have with DCEVM, with JBR, does require running on desktop at the moment. So how might you do that? Let's say that you already have a full stack app which is sharing Compose UI between Android and iOS. One of the things that you could do is you could add a desktop target alongside these, and you could have all of your implementations work on desktop too. This is what we have in the case of the Kotlin Conf app, for example. The full stack app is available on iOS, Android, Compose, iOS, Android, desktop, and web, having everything implemented from the UI layer all the way to the data layer, network calls, storage, and so on. But this might not be feasible for every app. You might have a lot of data layer integrations that you don't want to implement the same way on desktop, Bluetooth handling, sensors on mobile devices, whatever it might be. So you may choose to have a desktop app, which is not a real functional desktop app, but it can launch most of your UI, and you can navigate through the screens, and you just have some kind of empty or fake implementation for all the data layer things. Or you might create a desktop app which depends on your Compose UI, which is probably fairly platform independent, and it might not even have it set up with the same navigation structure and underlying data layers. It might just have a bunch of your Compose components thrown into a big list that you can scroll through or something like that, so like a gallery kind of setup. And that can also run as a desktop JVM app and give you hot reload for working with individual components. Or you can load screens in there one by one with just pre-populated data. So you have a lot of flexibility and options of how you're going to get some of your Compose UI into a desktop app so that you can work with hot reload. Some other fun things that I can show you is that, of course, we also use hot reload ourselves, such as building tooling and doing dogfooding. So here, for example, we have a version of the Toolbox app, which you can use to manage all your IDE installations. And that's also actually a Compose desktop application. So as our developers are working on that, they actually can also make use of Compose hot reload so that they can build new features in there without having to relaunch and repackage the app. And then, if you remember the chart I've shown you with all the different components and how they connect to each other, this actually has a lot of flexibility in it. So hot reload doesn't just work for standalone desktop applications like we've seen so far, but it also works in other situations where we are running Compose UI. So one of the recent use cases of Compose UI on the desktop is building UI inside of IntelliJ itself using Compose. And in this setup, we have two IntelliJ windows, with the bottom one being our IDE that we're writing Compose code in. And it has the code base of IntelliJ open. So it's running the IntelliJ instance on the top in like debug mode launched from the bottom IDE. And as you can see, if I start this video, as we're making changes to the Compose code, we get real-time updates of the UI on the top instance. So as we're working on new plugins for IntelliJ, or this is also available publicly if you're working on your own plugins for IntelliJ or Android Studio, you can actually make use of Compose hot reload as well, which makes it a lot easier to work on UI because you don't have to rebuild and relaunch IntelliJ every single time. OK, let me promote a couple more talks that you can go to after this one. So after lunch today, my colleague Seb is going to give a talk about Compose multi-platform for iOS that you can check out. Going to be in the dependency den. And we also have office hours or roundtable discussions or whatever you want to call them in the Android arena tomorrow afternoon, where you can basically show up and ask any question about Kotlin, KMP, CMP, anything JetBrains related. We're here for just about any questions. So with that, thank you so much for choosing to start the conference with this talk. Again, you can check out hot reload. You can check out the Kotlin Conf app if you need a sample. And if you want to dive deeper into the story of hot reload and how we built it and how it works under the hood, Sebastian Selmayr, who built most of it, has really good technical content on it, including a talk from earlier this year at Kotlin Conf. And that's everything. Thank you. Enjoy the rest of the event. Do we have time for questions? Yeah. In case someone immediately has questions, I'm happy to answer them. Yes? Yes. So the question was whether this is for KMP or you can also use it for standalone Android apps. It is for Compose multi-platform on the desktop specifically at the moment. We are looking at what we could do for other platforms. As I mentioned, the implementation is heavily tied to desktop things for now. But we're experimenting with especially native reloading and seeing if we can build something for iOS, for example. We'll probably also look at Android, but again, no promises for these other platforms. And I would also recommend asking Google about Android support for something like this, so that maybe they'll build something. Yes.
Yeah, along the same lines.
Oh, there's a mic. We have a mic.
Oh, thank you. Along the same lines, of course, like in big projects, it's kind of a big ask to migrate to multi-platform for just to benefit from this. So is there any like plans to maybe integrate it with a previews or something, like interactive previews where you could hot reload that thing? So at least if you're working just on a screen, you can hot reload that one.
Mm-hmm. So previews serve a slightly different use case, and for previews, you do have preview support already. You have it for Android, like pure Android apps, and you also have it for Compose multi-platform apps. So in both of these situations, you have previews, you have interactive previews, all of these features. So you already have all of those tools at your disposal. What Hot Reload gives you on top of this is mainly that you have a full application running and not just a small piece of your UI. So you can really have like a feel for like animations for navigating through your app after you're making changes. You can make changes to your logic. You can see what UI changes look like while you have maybe like an already logged in session and you have navigated to some screen with specific data loaded in there with the real things from your backend. So this having a full application is what this gives you on top of previews. But previews do work, and you do have things like interactive previews, and again, they work both for Android and for the CMP situation. OK, I think that's probably it for immediate questions. Again, if you have any other questions, find me anytime during the conference, and enjoy the rest of it. Thank you.